Hey guys, so today we are doing isosceles and equilateral triangles. There is a lot of vocab in this lesson, so basically the whole first page of notes is just vocab. You don't have to write too much, just make sure you follow along and ask if you have any questions. So by the end of the period, you guys will be able to apply the properties of isosceles and equilateral triangles. Isosceles triangles are common in the real world. You can frequently see them in structures such as bridges and buildings, as well as in art and design. The congruent sides of an isosceles triangle are its legs, and then the third side is its base. The two congruent legs form the vertex angle, and the other two angles are base angles. So make sure that you maybe highlight those or underline them, or kind of make sure that you understand what those are on the picture especially. So as you can see, there are a lot of examples in the real world with isosceles triangles. Okay, so the converse of the isosceles triangle theorem. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if angle A is congruent to angle B, those sides opposite, so A to this one, and then B to this one, are congruent as well. The theorem 4-3 is the isosceles triangle theorem. So those two, it doesn't matter what order they're in, but if you have two sides that are congruent, the angles across from them are also congruent. So for number one, what is the measure of angle A? So again, if you have two sides that are congruent, it means their angles that are across from them are also congruent. So if angle C is 70, angle A would also have to be 70. For B, if we have, so we're using theorem 4-4. If A is congruent to B, so if A is congruent to C, which they are, then the sides across from them are also congruent. And because of that, we can say that the measure of angle A is 53. You also don't really need this info here because it already told us that those two angles are congruent, so we can automatically assume that if angle C is 53, angle A is also 53. For number two, what is the value of x? So both of these sides are congruent here, so that means if angle D is x, angle F is also x. So how I set this up was I added everything to equal 180, and then I solved for x. So 30 plus x equals 180. I moved the 30 over and got 150. I added x plus x, which is 2x, and then I divided by 2, which is 75. For B, this is on actually theorem 4-5. So theorem 4-5. If we'll look at it in a second. If we have two congruent angles, right? It means that line bisects this here, and if it bisects that, or it is perpendicular. So those two are both 90 degrees, and we can revisit that one in a second here. Okay, so revisiting, or let's look at theorem 4-5. So if a line bisects the vertex angle of an isosceles triangle, then the line is also perpendicular bisector of the base. So if AC is congruent to BC, and then angle ACD is congruent to BCD, that means that the bisector is perpendicular to the line. So let's look at our number two. So we have the two lines are congruent, the two angles are congruent, so that means that this is perpendicular, which is a 90-degree angle. So I know that if angle ONM is x, this angle is also x. So I can add all those up, 42 plus x plus 90, and set it equal to 180, and then solve for x, which is 48. So then a corollary is a theorem that can be proved using another theorem. And then an equilateral triangle is a triangle with all equal angles and sides. So all of the angles equal exactly the same. All of the sides are exactly the same. Corollary to theorem 4-3, which was, your sides are congruent, which means your angles are congruent. So that being said, if all of the sides are congruent in an equilateral triangle, that means all of the angles are also congruent. And vice versa. So if a triangle is angular, so meaning all of the angles are congruent, it also means all of the sides across from that angle are congruent. Okay, so let's find the values of x and y. So number one, we're flipping to the back here. I told you this was going to be mostly vocab. So for number one, I know that this whole thing here is 180. Okay, so 180 minus 115 would give me what? Would give me 65. And because this is an isosceles triangle with these two legs here, x has to equal 65 as well. To get y, I know that the two base angles are 65, so I can say y equals 180 minus 2 times 65, and then I would get y equals 50. For number two, so you have this. We're going to set it up the same way. We know this whole thing equals 180, and if my little missing piece, these are both x's, so x would be 45. And then y, I would need to add up, my angles to get to 180. So 180 minus 2 times 45 would mean y equals 90. Number three is pretty tricky, okay? So this is a equilateral triangle. So that means that either all three sides are x plus 5 or all three sides are y minus 10. Y minus 10 equals x plus 5. But because we have two variables, it's going to be kind of hard to do. So what I did is I just started with x, and I know that if this is x plus 5 here, I could say that this side and this side, or angle, sorry, is also x plus 5. So what I did is I did 3 times x plus 5 equals 180, and then I distributed, and I solved for x, and x is 55. So that being said, if x is 55, that means that I could now set y minus 10 equal to x plus 5. And I know that x is 55, so 55 plus 5 is 65, and 65 plus 10, or sorry, 55 plus 5 is 60. Then if I add 10 to both sides, I end up getting y equals 70. I want you guys to try 4, 5, and 6, so pause the video and go ahead and give those 3 a try. Make sure to draw on your pictures to help you get your answer. So for number 4, again, this is an equilateral triangle, so we're going to set it up the same way that we did number 3. So I did my x's first, and I know that if all of these angles are exactly the same, I could substitute in 2x for every single angle in this triangle. And when I do that, I got x equals 30. Then you know that these two angles here, all of these angles are congruent to each other, right? So we can set 3y equal to 2x, and I'm going to plug in 30 for x. So then you'd have 3y equals 60, and then you divide both sides by 3 and get y equals 20. I guess I didn't want to do that soon, but x, I know this whole thing here is 180, so 180 minus 110 is 70. Then, if you know that x is 70, we can figure out y by just doing 180 minus those other pieces. So 180 minus 90 minus 70 would be 20. And then for number 6, so this is not as tricky as it looks. So we know that these are isosceles triangles, okay? And this is reflexive, so that would be congruent to itself. Now, if we know that this is 90, this is obviously a square, Okay, so if this is 90, these guys also have to be 90 in order for all of those sides to be congruent to each other. So y, technically, we would have to do like 180, obviously, minus 90, which equals 90. And 90 divided by 2 is 45. So that means that y and x are both 45 because all of those angles, the corners equal 90 degrees. Now for 7, 8, and 9, so this is not as tricky as it seems, but we are only finding one angle measure here. So we are trying to find the measure of angle ACB, which is right here. Okay, so if I know that that triangle is an isosceles triangle, that means angle ACD is 45 as well. And I can use my linear pair postulate. I know that whole piece there, that whole line, straight angle, is 180 degrees. So I can do 180 minus 45, and I would get ACB equals 135. For angle DBC, so I'm looking for right here, if it will let me draw on there, DBC. I know that this is an isosceles triangle, so obviously this would be 70 over here, or these two pieces would be congruent here, or that whole thing divided by 2. So we'd have 180 minus 90 minus 20. Sorry, this should be a 70. I messed that up. It should be a 70. Equals 20. For number 9, this is kind of tricky, but you know that the bottom triangle CDE is an isosceles. So angle CDE is 55. That means angle CED is also 55. Then we can add, do some 180 minus stuff and do 180 minus 110, which gives me 70. These two angles here are congruent because they're vertical angles. So ACB is also 70 degrees. And if ACD is 70 and this is an isosceles triangle, that means these two have to be congruent as well. In 180 minus 70 is 110. These two triangles are similar triangles. They're not congruent, obviously, because the lengths are different, but they are similar because their angles are the same. So the measure of angle ABC is 55. Okay, so the wall at the front entrance to the Rock and Roll Hall of Fame and Museum in Cleveland, Ohio is an isosceles triangle. The triangle has a vertex angle of 102. What is the measure of the base angle? So basically, you need to draw a picture, okay? So I drew my picture here. My vertex angle is 102. Again, if you don't know the vocab, you need to make sure that you try and get that figured out. So basically, your two base angles have to add, all your angles have to add up to 180. So your base angles is 180 minus 102, and you get 78. Then you have to divide that by 2 because those two angles are exactly the same. So 78 divided by 2 would be 39. So your base angles would be 39 degrees each. For number 11, so this, you can do two different ways here. The exterior angle of an isosceles triangle has a measure of 130. So that means it is outside of the triangle, okay? It has an extra line coming out of the triangle. So it looks like these guys, okay? Remember that exterior angle is out here. So I drew it in two different ways. We have 130 on the base side, and we have 130 on the vertex angle side. So you can either have these two options. You have 80 and then 50 and 50, or 50 and then 65 and 65. So those are the two options for that. Next, so number 12 is, once you get into, the multiple triangles in one, it gets a little complicated. So, first of all, I did this triangle here because that one was the easiest to me. So that is an isosceles triangle, but it is also a right isosceles triangle. So if I know that I have 90 and 45, for M, that obviously has to be 45. Then for the other triangle, I know that this whole thing here is M plus N. M is 60, so if I do, sorry, that is not correct. Hold on, let me erase this and try it again. So this is 45. In my other triangle here, if this angle is 60 up here and these two sides are congruent, that means these two angles also have to be 60, because 180 minus 60 is 120, and then 120 divided by 2 is 60. So then I did M plus N equals 60. I plugged in 45 for M, and I got N equals 15. For number 13, so you can do a couple things here. We know that this is an isosceles triangle, so 68 and 68 have to be on the bottom. Then you can figure out from there that the vertex angle would be 44. But these two are both M because they are vertical angles. So if this is 44 here, that means that M is also 44 at the top there. And that being said, if this is 44, you can only have two options here for N because they say that they are congruent in the first place. So M has to be 44, N has to be 68. Then for number 14, oh, I didn't want to do that. There is a lot of stuff going on here. So I know that this whole thing here is 90. So if this is 15, then the other piece has to be 75. And because this is an isosceles triangle, this has to be 75. Then I can do some simple math and do 180 minus 150 and get 30 up here. Then to get my missing piece here or here, I would have to do 180 minus 15 and I would get 165. If I divide that by 2, I get 82.5 that would go here. To get M, I would do some subtraction. This whole thing is 180 here. So 180 minus the 82.5 minus the 30 is 67.5. And then from there, if I do 180 minus 67.5, which is 112.5, and I divide that by 2, that gives me these two pieces here, which would be 56.25. Like always, if you guys have questions, let me know. Send me an email through Canvas or regular email. And yeah, good luck.